Hello everyone, welcome to this session on AWS and VPC and basic networking concepts. We're welcoming Joy, who's going to be leading the session. Over to you.
Okay, hi, welcome everyone. I'm Joy, and we'll be going through AWS and basic networking concepts in this 15 minutes lightning talk, where we will explore how AWS, which is AWS VPC, also known as the Virtual Private Cloud, forms the backbone of networking in AWS. Now, whether you're a beginner or an intermediate, this section will help us visualize and understand how AWS handles private, secure, and a scalable networking environment. But before we dig in, I would love to introduce myself. I'm Joy, and I'm a DevOps engineer in a leading fintech company here in Nigeria that specializes on-prem, cloud infrastructure, and CI/CD pipelines and system scalability. Now, I've made use of other cloud providers during my during my career journey, but I have come to understand that with using AWS, the user experience is kind of easier for especially beginners who are trying to understand, okay, what is VPC? How does networking? How do I create a secure system or a secure environment? Now, whether you want to be diving into networking on your own, or you want to start building, or you work with a company that makes use of AWS, it won't be long before you're asked to put resources within your VPC. So we'll be digging in and understanding how you're likely going to customize your VPC to make sure you have a secure environment. The next slide. What is an AWS? What is an AWS VPC? Please hold. So, what is an AWS VPC? So, from my understanding, because I love breaking things down, in the simplest form, just see AWS VPC as your own data center inside AWS cloud. Now you're building your own network filled with routers, your firewalls, your gateway, without the hardware, without thinking of, okay, what are the hardware systems or hardwares I need to buy to set up my own data center. Now you're going to be the data center inside AWS, and you have complete control over your VPC, from the creation to the customization, even to the deletion. So once you've set up your network and you're not satisfied with the setup, it's okay for you to delete and start afresh. Now, this diagram we have on this slide is a diagram that shows an architecture, how resources are being organized, showing that these resources have high availability, they are scalable, and they are fault tolerance. You can see that in AWS we have something called a region. A region is where multiple data centers are located, and these data centers are used to ensure high availability of resources in AWS. Now, from building your VPC, before we even start putting in resources into the VPC, we have something called this understanding decider blocks. Now, this particular concept, decider block, has been a very confusing Hello? Okay. Sorry about that. Let's talk about cider blocks. Now, continuing with cider blocks. Cider blocks is one of the aspects as a DevOps. When I got into DevOps field, it was one of the things that were very, very confusing for me. So I had to research, read a lot about it, ask questions, and watch a lot of YouTube videos to understand what cider blocks is all about. And I keep seeing questions popping in when people keep asking, how do you build your IP addressing? How do you know that, okay, this is the IP range you're supposed to use in your VPC? So AWS cider blocks, or also known as classless inter-domain routing, helps you define your size and the range of your VPC. Now, AWS helps you pick your IP ranges. Either you're using a 10.0.0.0 or you're using the 192.168.0.0, or you can even use the default AWS VPC CIDR block, which is 172.31.0.0/16. Now, how this CIDR block works is that for every number on this CIDR blocks is called an octet, which represents 8 bits. So it means we have, this is 8 bits, 10 is an 8 bit, 0 is an 8 bit, the next 0 is an 8 bit, the last 0 is also an 8 bit. It means we have 24 bits. Now, what this means is that in the first column, what this means is that you have more IP ranges to use. So let's say, for instance, you're creating a VPC and you assign a range of 10.0.0/8. It means that the first three are empty and free for you to use. And when you check 8 plus 8 plus 8 plus 8, it means 16. So when you times this, multiply this, it means you're going to get 16,770 something million IP ranges to use. So it means it's easier for you. The more you have a lower CIDR range, the higher the resources you can put into your VPC. Now, if you go over to the one of 16, the 16/16, sorry, you're going to see that the ranges you have has also reduced. So this is how you determine the private IPs in your VPC. This is how you determine, okay, do I want to have more resources or do I want to have bigger resources? Now, remember that when using AWS VPC, AWS reserves 5 IP addresses in each subnet for internal use. So whenever you're assigning a CIDR block range, always bear in mind that AWS will make use of 5.
Sorry to interrupt you, Joy. So sorry, we can't see the slides.
Subnet.
So is it possible? Do you have a slide for what you're discussing right now? Yeah. So now. Yes, now we can. Thank you.
Okay, sorry.
Much.
Oh,
no
I thought I was moving the slides. Can you see them now? I'm so sorry. So sorry, I thought the slides were moving. So we've spoken about AWS VPC and the CIDR blocks. Okay, sorry. So I explained the CIDR blocks and I was given an instance, sorry. And I said that when using your CIDR block and assigning IPs to a VPC network, the lower the slash, the lower the octa sign you're giving after, the higher the IP ranges. So I also want us to have in mind that when creating your own network, it means that AWS always reserve 5 IP addresses for themselves. So if you're using this, it means that AWS is going to take out of this 10.255 or 255.255, AWS is going to get 5 IP addresses reserved for itself. So whenever you're assigning an IP address range, always bear in mind that AWS makes use of 5 IP addresses. Now let's go over to subnets. So inside our VPC, we can't just put resources inside the VPC directly. There's something called subnets. They are a logical way of dividing your VPC into smaller networks. Now from the one of the slides, you can see that each subnet has its own availability zone, right? And its own availability zone means I can decide, okay, availability zone A or availability zone B. I can say, okay, A is for my web servers and B is for my DB servers. Now, the subnet also helps us know which resources is supposed to go out to the public and the ones that are supposed to remain privately, they're supposed to communicate or remain within our VPC. Now, subnets are a way of dividing your VPCs, and we have 2 different major types of subnet. There are other types, but for beginner level, you should always bear in mind that you have 2 types, the public subnet and the private subnet. And every subnet must have or must reside in one availability zone. So from this diagram, I'm going to see that from the public subnet is connected via the internet gateway. So you can see the internet gateway, while the private subnet is isolated and is not connected to the internet. This means that resources inside your private subnet cannot speak to the public internet. It does not have any communication whatsoever to the internet. So a logical or a real world analogy that we use for this is that when you have multiple rooms in your house, and then you have your living room, which is open to guests, also known as the public subnets, and then you have your private room, like your bedroom. This is private, and not everyone should have access into your bedroom. Now, the resources you place in subnets, you place resources in a subnet depending on the access you need, or the access you need those resources to have. We'll go over to, so let's move over to and understand how security groups. Now, when it comes to VPC, like I said, VPC is a way of building secure network, right? But VPC and your subnets aren't just the only security you're going to have. There's something called security groups. Now, security groups are like your mini firewalls. In a network environment, you should have a firewall. The firewall is what controls your traffic, whether incoming or outgoing traffic. Security groups is like a mini firewall, your own firewalls inside AWS, telling, okay, this traffic, which is your incoming, also called the ingress, or the outgoing, called the egress, which should this resource accept incoming traffic, or should this resource not accept incoming traffic? Now, from this diagram, we see that in our public subnet, there's a security group for 2 instances, and each subnet have their own security group. Now, security groups does not secure a subnet. What security group secures is your instances, resources, like your DBs. That's what security group secures. It's just a firewall protecting resources that are already inside the subnet. Now, like I explained, we have the VPC, and then we have the subnet. Then inside the subnet, that's when we can now put resources inside each of these subnets. Now, to be able to protect or provide more security to these resources, I will have to have a security group that is saying, okay, I need resources inside here to be able to communicate. It's a first line of defense, actually, that you say that, okay, controls traffic and say, why should you have to, it's a set of rules. You will decide whether to allow traffic to reach an instance and evaluate those rules and see, okay, should I allow this instance or this database to be reached on port 80, or should I allow it to be reached on port 90, or should I allow this IP to be able to talk, or should I just open it to the whole internet, or to the public internet? Anybody can reach this server. Okay, let's go over to the route tables. Now, we've discussed about our security group, right? And then we are saying in security group, we are trying to understand, should traffic hit this resource or not. Now, for us to be able to say, okay, this is the way, or this is the route, this is the route this traffic should follow, or this is the way this traffic should follow to hit our VPC, the route table comes in. The route table is what tells our traffic where to go, whether it should stay within our VPC, or it should go to the internet, or it should go through a NAT gateway, or even through a VPN connection. Now, proper routing ensures communication flows. So a route table is used to specify which network your VPC should communicate with, or you shouldn't communicate with. So by default, VPC comes with a single route table, also refers to as the main route table. However, you can create multiple route tables, right? Multiple route tables route tables have 2 specific properties. There are many properties of a route table, but it has 2 specific properties, known as, 1, the destination. Now, destination is known as the set of IP addresses where you want your traffic, also called the destination CIDR. Think of it as the CIDR block, or a group of IP addresses you want to direct your traffic to. Now, the target can be your gateway, your network interface, or a connection to send destination traffic. So you think of these as the path, or the specific method to send your traffic to its destination, or where it needs to go. Now, the route table is like a map. It's a map that tells the VPC, it's a map that tells the network, the traffic, where to go or where to pass through. It gives the network, the traffic coming into your VPC, it gives it the destination, and also gives the target. Now, before we are able to say, okay, from this table, you can say that we have an internet gateway here. That is one of our targets. Now, let's discuss about how our resources are being able to reach the internet, or be able to communicate to each other within the VPC. Now, remember I said we have a private subnet and a public subnet. And when you have resources in your private subnet, they cannot speak to other resources within the VPC except through a method called the NAT gateway. Now, the NAT gateway is what allows your resources to talk to each other, or even talk to a public subnet. While your internet gateway is what allows or sends and receives public traffic. Now, before your resources or before instances, maybe your EC2 instance, your RDS instance can be able to speak to the public internet, it needs an internet gateway where it can send and receive public traffic. However, public traffic cannot directly be accessible when using a NAT gateway. So what NAT gateway does is that if I have an EC2 instance, for instance, I have an EC2 server, and I want to be able to, let's say, update that server, run sudo apt upgrade or sudo apt update on that server, but I don't want that server to be able to receive traffic, I will make use of a NAT gateway. And making use of a NAT gateway means my EC2 instance can be able to upgrade packages or update the libraries inside that server, but no server should be able to speak to it. That is how internet gateway and NAT gateway works. So internet gateway enables resources in your public internet to connect to the internet, while NAT gateway allows these resources in your private subnet to access the internet securely without the internet reaching back into those resources in your private subnet. Now we have to look at, sorry, I think I skipped something. Hold on. Okay. So after the internet gateway, we'll now look at how VPC, the best practices while using VPC. So we all know that while building our own data center, we want security. We don't want to wake up and say, oh, we've been hacked, or we don't want to wake up and say our system is down due to DOS attack. Now, you always need to check. Always, there are some key things you need to look into while building your VPC in AWS. Make sure that in as much as VPC provides you isolation and control, your CIDR block range should be well defined. It shouldn't be something you just wake up and say you're provisioning a VPC. It should be well defined. You should make sure that you have your security groups in place and define which port can reach, even if it's your public subnet, which port should be able to talk to the resources inside my public subnet. That's where security group comes in. We also have something called the network access control list. So this network access control is another form of security, which I don't have which is another form of security list in AWS, which is too extensive for this particular talk, but it's another way you can read about it. It's another way of providing a level of security, a layer of security into your VPC. Now, your internet gateway and your NAT gateway is another way to make sure that you protect your resources from internal and external world. Before you deploy VPC, always plan. So you need to plan and say, okay, you have resources, or your task, the responsibility of provisioning a VPC. You always need to sit down and plan and say which resources should be able to speak to the outside world and which resources should not be able to speak to the outside world. Something like your database does not have any reason to speak to the outside world. Database or backend applications are supposed to be speaking to other applications, right? So you need to properly sit down and plan and say, okay, this is where I should put these resources. Your front-end servers can be publicly accessible. That is okay. Those ones can go into your public subnet. Now, while also using VPC, always make sure that you enable something called VPC flow logs to monitor and audit traffic. It's very important to make sure that you're monitoring how traffic is moving in and out of your VPC, and to also know in case anything happens. So that's where you, aside for auditing, it also helps you to check to know, okay, maybe I mistakenly provisioned or allowed this particular private subnet to be able to speak to the internet. That traffic shows you what is really going on and how, maybe even if it's your public subnet, the number of traffic that is hitting it. So to know if there is more security layers you can apply to it. Now, always check VPC limits, like the number of your VPC you can use per region, the number of subnets you can use within a VPC, your elastic IPs, plan your network architecture. Always have a team, always collaborate with people in your team and ask them, keep the database, which database do we think, even if it's a test database, what can we do and how can we make sure that even if it's in a public subnet, how can we secure it? And remember to only expose your front-end servers to to the internet. Now, VPC is a foundational component of everything in AWS networking. So having a solid background in this concept is necessary. We've only touched on some of these things, right? But you can explore more on your own. You can also look at, I have some resources here that I use. Some of these resources have really been helpful and impactful. You can also look at these resources and say, okay, AWS documentation is well self-explanatory and well documented, well detailed. It will give you more insight on how to secure your VPC and secure your resources. Thank you so much. You can also reach me, in any of these socials. These are my socials.